Okay, in the last in last couple of videos we discussed regression, where we saw that the target variable basically might be a continuous value. It may not be class categories or stuff like so. And regression was also a supervised learning in a supervised learning paradigm. In this video, I'm going to talk about classification. And classification differs from regression in a way that, again, the features are again the same. Maybe feature 1, feature 2, feature 3, you may have a lot of features, let's say D features. And then you may have a target, and here I'm calling that target as a label or class label that you want to predict. But in classification, this target label is actually represents a class category or label. It is one of some finite set of categories. For example, it may be a category like vehicle. Let's say these are image features. A lot of image features, maybe just the pixel values or intensity values, and the label might be it's a vehicle image or pedestrian image, or it's an image with image empty row or empty image, which means it has no interesting object other than road or stuff. So these three are, these are not just continuous values, these are category labels for this particular data. So these kind of problems are called classification problems, in which, and these are very, very famous problems, very popular problems, several problems in industry as well as in academia, in businesses, in several, in most of the places, they fall under mostly either regression or classification most of the times. So for example, if you want to build a face recognition app. So in face recognition app, whatever program you come up with, it will receive a face image in some form. Obviously that form will be a feature form, whatever the features you are considering for that face image. And it will output one of the available face IDs in which it can fall. So for example, face ID 1, that 1 may represent person 1 or whatever the person 1 is, or it may be person 2, it may be person 3, it may be person 4, and so on. So that's also a classification problem. So in classification problem, your target label, your target attribute is actually a class label. It belongs to one of the, it belongs to a finite set of categories. These categories might be in a string form, might be in a text form, but it is always handy to convert these categories and to code these categories as numbers. So for example, in this particular case, vehicle may be coded as class 0, pedestrian may be coded as class 1, and empty may be coded as class 2. So eventually, when you will see a lot of classification data sets available on several places, for example, machine learning repository at UCI, you'll be seeing the target labels are mostly in numeric form. Although if you see the description document of the data set, there is a description document on several data sets that are available on, particularly at UCI machine learning repository. You'll be seeing that the description actually contains what do we mean by 0, what is that, what do we mean by 1, what is that, and so on. Not only this, they also have the attribute information as well. So that's classification. In classification, the difference between classification and regression is the type of the target we have. In regression, the target is continuous mostly, and it represents a quantity, a value. In classification, the target is a label, and it represents a category. So in the next video, we will go to Jupyter Notebook, our friend Jupyter Notebook, and we will be getting our hands comfortable with classification by just coding an example of classification in scikit-learn. Later on, we will see how to build later on we will be giving you examples of building at least a few models from scratch as well. So hope to see you in the next video. in this video, I'm going to give you an example of classification on iris dataset, which has 4 features. I've already shown you that in some earlier video. Maybe the data is loaded here. Maybe I should have shown you if this is here. No. Yeah, this is the iris dataset, if you remember. So I'm going to show you a classification example using a built-in model available in scikit-learn support vector machines, just to give you a look and feel of what classification is. Don't worry, later on we will be building a few models from scratch as well, just to give you a hands-on experience if you want to build these models from scratch. But right now I'll be using scikit-learn for this purpose. So first of all, let's load the data. sns.load dataset. Let's say iris dataset. Let's load this dataset. So let's see the data, just to get a look and feel what the data is. This is the data, and this last column is basically the column that is of species. That's the class column. So what we do next is the following. We first separate out the class label, which is x dot species. Let's get that out. Maybe we call so now we have this y. That these are all the class. So these are the target attribute that we really need, y. And next what we do is we delete this column from our original data to get the data in a format that we really want. So let's say x equals to x dot drop, let's say columns, what columns you really want to drop, or species. These are the columns that I really want to drop. So now if you see x, this x is this data with 4 features. If you see the shape of x dot shape, that is 150 samples with 4 features. And if you see y dot shape, that is basically 150 categorical variable. So now what we do is we train some model from scikit-learn. But before training, what we really do is so let's train some model. Let's train some model from scikit-learn. From sklearn learn.svm import svc. That's a support vector classifier. There are several other models as well. Let's import this one. Then we build a model just like we did in regression. We build a model like svc. There are several parameters in that we want to give. So let's give gamma equals auto. There are other parameters, don't worry. I'll explain those parameters when we'll explain SVM. So after that, what we do is we fit the model, m.fit xy, and the model should work, and that's what it does. Now m is available, m is fit. Now we predict our values using m.predict on x, simply x. So y is predicted. Now we can see what is the actual value y and what we really predicted. So let's just see what are our predictions. These are our predictions, all of these, and what we really our original values. So these are our predictions, and we can also see the original values. For example, y original, that is this. So I guess a first few of those are all setosa. Then we have a lot of versicolor here in predictions, and then we have all virginica. So I guess this is 100% right now. You might be thinking, what's the point of predicting the labels that we already know? Well, later on we will see. Actually, we use the training data, we use this data that is available to build a model. Once the model is available with us, this M model is available with us, then this predict function is able to actually predict the classes on the samples that were not available in the training data. And now you can deploy that model everywhere once you have learned the model anywhere, and whenever the feature values are available, the model will able to predict the class labels. So in this video, I have just given you an example of classification. What do we mean by classification? And I have just shown you one classifier from scikit-learn, which is support vector machine. I'm planning to actually give you coding from scratch of at least a few models for classification, as well as regression, as well as clustering in separate videos. So yeah, in the next video, I'll be going to discuss another learning model, unsupervised learning model called clustering. So hope to see you in the next video. In the last couple of videos, I discussed classification, just a definition and a few examples. In this particular video, I'm going to discuss clustering, which falls under unsupervised learning. By unsupervised learning just means that we are available with data X, or maybe the features F1, F2, F3, Ft, but there is no target upon which we want to learn a mapping. No target is available. So Y is not there. The target is not there. All we have is we have a lot of data set. We have a lot of records of the data, so this is the first sample, features. We have second sample, features. We have third sample, its features, and so on. We have a lot of data set. And we want to group the data in different groups. So based on certain similarity. I mean, for example, let me give you some data sets. For example, that's a data point. That's a data point. That's a data point. Let's say that's some data. That's another data. Let's say that's another data. That's a data. That's a data. That is some data. Obviously, we should represent this data in features and numeric form, but let just give you an example. That's data. And now if I ask you to just group them, so what you can do is you can label, you can call this belongs to group 1. This you can just label each and every object to its group. This also is of group 1. This is also of group 1. This is of group 2, this is of group 2, this is of group 2. This is of group 3, and this is of group 3. And that's what the clustering is. You need to group different objects together based on their similarity. And the similarity is defined in different ways, depending upon the requirements and depending upon the semantics of the data, available data. You might be thinking, here we also are producing labels, so how this clustering is different than classification? Well, we are just grouping. For example, we have made this particular group. We have made this as a group. This one, that's a group. We have made this group. In this group, all these three objects are similar. They are similar to each other, but we do not know what is the identity of this group. Because we were not available the labels or the categories earlier. If, for example, the categories or the labels were available earlier, the grouping has been done already, because the labels, they are the labels, they actually define the grouping. But we need to come up with these labels. We need to come up with these labels based on the similarity among the different objects. So, for example, if you're available with this data and we just want to group all the data into 3 different groups, then one way to generate the output is to add another column in the data set and just write the group label in front of it. But you have to write the group label in front of each data point or a feature vector. I will explain what do we mean by data point, what do we mean by feature vector later on. So you have to write the group labels here, and once you're done with that, you actually have done clustering. So So originally the labels were not available. Based on similarities, you group them together and you generate different labels. So that's group 1, that's group 2, that's group 3, and so on. Or each a particular sample belongs to what kind of group. You need to come up with that. So in the next video, I'll be showing you a clustering example in Jupyter Notebook, again using scikit-learn. So hope to see you in the next video. Okay, in this video, I'm going to talk about actually a clustering example on synthetic data. So let's generate some synthetic data. I already have imported this make blobs, but let me re-import it just to show you that I'm going to generate some synthetic data. Datasets, import, make blobs. So let's say this is our data set, make blobs. And then let's say we have X and Y, that is equal to make blobs. Number of samples, let's say equals to 200, that's 200 samples. Total centers or classes, let's say we have 5 classes maybe. That's it. Let's generate this. Let's say this is our data. Let's plot the data and see what the data looks like. plt.scatter x. That's data with just 2 features. So feature 1 indexed with 0, feature 2 indexed with 1. So let's get the data plot. That's a plot. So yeah, so this is our plot with 5 centers. So maybe we should generate more data points, let's say, to see different centers more concretely. Yeah, so why it is not generating 5 centers? Why it is generating just 4 of them? So maybe due to cluster standard deviation. Let's set the cluster standard deviation as, that's a 2. Oh, that's high. I should reduce it. Because the more standard deviation means the more varied the clusters are and they will intermix. Let's say the cluster center is cluster standard deviation is just 0.3. Oh, now I have 5 clusters, beautiful ones. Let's take it around 6, why not? So these are my 5 clusters, let's say, originally. This is the data. I do not know which point belongs to which group, but based on their similarity in between, I just want to group them. So let's try to group all this data. If you see, for example, the data, if you see the data, x.shape, that's our data. It has 500 samples and 2 features, and now we want to group them, let's say, into 5 different groups. So let's use a model from scikit-learn that we will later code from scratch as well, which is k-means clustering, sklearn. So we will be coding k-means clustering from scratch, no problem, in a later video. So right now I'm going to just use it, k-means. So then let's see if it is imported very well. Yes. Then k-means equals, let's build a model. K-means, again, like we build all our models, total number of clusters. How many clusters are there in which you want to group your data? Let's say 5. These are the clusters. So now k-means dot fit, and we want to fit it on X. Once fitted, we now want to predict the groups for Y, or Y predicted, or the groups, or let's say Y predicted, which means the group labels, which is k-means dot predict on X. And later on, what we can do really is we can just plot it by by different colors based on the group labels. So let's say plt dot scatter x 0, the first feature, then the second feature, which is indexed by 1, and let's say I want to plot all of them with categories as my predicted labels. You can set the color map. So let's say CMap color map as, and there are several color maps. Let's say autumn, or you can have autumn, or you can have where it is. I mean, there are several color maps. So let's do it. So let's see what happens. So different colors mean different groups. You see that? I mean, the same group got a same color. In this particular case, it has not made a lot of errors. I mean, it actually figured out that all these data points, they are similar based, and the similarity here in this particular algorithm is used by the distance between 2 points. We will see that later on when we'll code k-means from scratch. But that what we mean, I mean, given data, you need to group the data into different groups, and they now represent the group labels. And this is true even for higher dimensional data when you have a lot of features available. And k-means is not the only clustering algorithm. There are a lot. I end this video here. In this particular video, I just showed you an example of clustering using k-means algorithm from scikit-learn. We use the function from scikit-learn, which I'm promising you that we will code ourselves from scratch. And we already have coded some examples from classification and some examples from regression. So this video actually concludes the unsupervised and supervised learning examples. And after this video, you should be comfortable with what do we mean by regression, what do we mean by classification, and what do we mean by clustering. Later on, we will be moving into more depth of these models and different kind of models, and a lot of implementation details and factors related to boost the accuracy of the model and stuff like so. So hope to see you in the next video.